In this question, we have to find the bond angle between nitrogen and oxygen in nitrate, the NO3- ion. To do this, we have to do several things. Step 1, write the Lewis structure. Step 2, determine the shape. And then step 3, remember the bond angles for the different shapes. Linear is 180, trigonal-planar is 120, and tetrahedral is around 109.5, or is 109.5. So, let's start by drawing the Lewis structure. To draw the Lewis structure, we have to count the valence electrons. So nitrogen has 5 plus 3 times 6 plus 1 extra because it's NO3-. This gives us a total of 24 electrons. In this series of videos, I go through several examples of how to write Lewis structures. There's also a Lewis structure set of videos where I actually go through NO3- exactly. It's on the last video, video 5, of the Lewis structure series. Here I'm going to do it relatively quickly so we can get to the other parts of this problem. So we put the least electronegative atom in the middle, nitrogen. We bond it to 3 oxygens. Like so. I've used 2, 4, 6 electrons, which means I have 18 of the 24 electrons left. Another thing I might notice is that 24 is evenly divisible by 8. So if I put 8 valence electrons around each oxygen, the 2 in the covalent bond, plus the 6 electrons in the lone pairs, and I do that to all 3 oxygens, 3/8 are 24, and it saves me some counting time. Now, my goal was to fill the octets. I do not have full octets here. Nitrogen doesn't have an octet. Well, if I don't have enough electrons and I want to make up octets, I need to make a multiple bond, which gives me N double bond O, like so, bond O, bond O. Now I'll calculate formal charges, because now I've filled the octets of everything. Well, oxygen likes to have 6 electrons around it. Count the dots as 1 and count the dashes as 1. How many electrons does oxygen have around it? 1, 2, 3, 4, 5, 6, 7. It has an extra electron, so it's negative. This oxygen is the same. It's negative. How about this oxygen? 1, 6 has 1, 2, 3, 4, 5, 6. 1, 6 has 6, so it's neutral. The next one is nitrogen. Wants to have 5 valence electrons around it. How many does it have? Count the dots as 1, count the dashes as 1. 1, 2, 3, 4. If it wants 5 and has 4, it's positively charged. It's missing an electron. So one thing you might notice here is, well, step 4 is to minimize the formal charges. I can make these formal charges better. Maybe I take these electrons and I move them into another double bond. Let's see what that looks like. So I just essentially moved these 2 electrons into a double bond, and I kept all else the same. This is minus. This oxygen is now neutral, because when you take it a lone pair and you move it into a double bond, you essentially take 1 electron away from oxygen. This nitrogen is also now neutral, because when you take the lone pair and move it into a double bond, that 1 electron that you took away from oxygen is now around nitrogen, because now it's bonding with nitrogen. So this goes to 0 and this goes to 0. So this is now 0 and this is 0. We can count it just to make sure. Oxygen wants to have 6 electrons around it. Count the dots as 1, count the dashes as 1. It has 1, 2, 3, 4, 5, 6. 1, 6 has 6. It's neutral. Nitrogen wants 5 electrons around it, and it has 1, 2, 3, 4, 5. Wants 5, has 5, it's neutral. The question becomes, which Lewis structure is better? This Lewis structure has more formal charges, so in that sense, this Lewis structure looks better. However, this Lewis structure is not allowed. And the reason for that is, if you have an expanded octet, there's actually a total of 2, 4, 6, 8, 10 electrons around this nitrogen. Nitrogen is not period 3 or lower on the periodic table, so it cannot expand its octet. This is the best Lewis structure of nitrate. Now, we still have to answer this question. It asks for the best bond, or the bond angle between oxygen, nitrogen, and oxygen. How are we going to figure that out? Well, to do that, we need to find the shape. The molecular geometry here, we have, with respect to nitrogen, 1, 2, 3 domains, 0 lone pairs. So if we use our sheet, this one I printed off Wikipedia, you can also find this in your book. We have 3 domains, 0 lone pairs. It's trigonal planar. This is trigonal planar. Note that trigonal planar is both the electron geometry and the molecular geometry because there's no lone pairs on nitrogen. What is the approximate bond angle in trigonal planar? Well, the approximate bond angle is 120 degrees. Remember that VSEPR, valence shell electron pair repulsion, which is what we're talking about here, and where these shapes come from, is simply the arrangement in three-dimensional space that keeps the electrons as far apart as possible. So it turns out that if you have 3 things around the central atom, as far apart as these electron groups can be is all in one plane, 120 degrees apart. So there's a lot of work to do to solve this problem, but first we drew the Lewis structure, then we found the shape of the molecule, then we memorized essentially the bond angles for the different shapes, and for the first 4 domains, 2 domains, 3 domains, and 4 domains, we have the different electron geometries and the approximate bond angles here.